All right, hi everyone. Today what we're doing is something called slope fields. And what a slope field is literally in the expression slope fields, like a mine field. A slope field in very similar fashion is a lot of points on a grid, and these points reflect not mines, but slopes. Okay, so what we're looking here is a illustration of a slope field here. The equation is on my left. Is you can see y is 2x over y, and that is our slope. These are not line equations. These are slope. Remember, slopes are just how much something is changing. And as you progress across the graph, the slope changes a lot. Now, let me give you an example of a slope that we have. So just real quick, let's go back and forth between this illustration and this example over here. If I give you the graph, y is equal to x squared. What is the slope of this graph? We can find the slope very easily by saying y prime is equal to 2x. Okay. Now, if I look at y prime is equal to 2x, well, great. We know the slope now is 2x. But if I want to go backwards, do we get our first original graph? Imagine if you walk into a room and all you see is the slope is 2x. Do you know what the original graph exactly looks like? No, you just look at the trend of a graph. If I could log your speed in a car, imagine if I had a speed recorder, not a GPS, just a velocity recorder on your car. And it says you're driving 20, 30, 40 miles an hour. But it doesn't tell you where you're at. So here's my problem is, if I give you the graph, that's x squared, great. Okay, this is what x squared looks like. But what does the slope look like? This is y. Y prime looks like 2x, which is this graph here. Okay, 2x. But if I tell you to go backwards and draw me, what would the actual graph look like? Well, is it here? 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 And if I do take the integral of 2x, we end up with this answer, x squared plus c. And that c is a constant that we don't know. Unless if I give you any further information, you do not know where we originally started with this graph. Now, just let me go ahead and change this on my left here. Come on, don't break. If our slope is 2x, if you take a look here, it's hard to see, but you will see actually we are drawing parabolas. Now, let me go ahead and take a screenshot and show you what I'm talking about here. So what a slope field is, it's the slope of every x and y point. So at 0, 0, what's the slope? If I plug in the slope here, if I plug in 0, isn't the slope just 0? So we draw a horizontal line. What's the slope at 1, 1? 1, 1. Plug in 1 here, the slope is 2. As you can see, it's a little more curvy. What's the slope at negative 1, 1? If I plug in negative 1 here, that's negative 2. As you can see here, it's negative going down. Now what happens is the slope field literally is me plugging in every freaking xy value on a graph, and it gives you a trend. And what happens is we now follow this trend. If I start at 0, 0, take a look here. This is where the trend is curving me toward. What if I start over here? Take a look here. It's telling me to go down, right? It's going down. It's probably going down. It's probably a pretty big loop. What if I pick the point here? You see it's kind of telling me, oh, get over here. Oh, go straight now, go straight now. Oh, go back up, go back up. And what these slope fields are, they give us a rough idea of what the original graph would look like. Because slope fields are just a little bit of slope, a little bit of change. But if you put enough change, it kind of tells you where to go. I oftentimes think of these as if I had a paper boat. Anyone ever play with a paper boat? Like you fold the paper boat and then you throw it on water? And doesn't the boat just kind of start drifting in different directions? And those directions are based on which way the water's flowing. So if I drop off a boat over here, take a look, the boat's gonna float in this direction, and then it's gonna get caught in this current, and then get caught in this current. And this really reminds me of, like what I mentioned before, what happens with ocean currents. And this is what I want you guys to see. You guys might have seen a picture like this before, and this is, in a sense, this is a pattern of water. This has not only direction, it also has magnitude. Magnitude means how strong it is. You can see these arrows are super strong here, right? And some are very weak. But imagine if I was a boat and I got caught in this current. If I was caught adrift. If my engine stopped here, you can see that the currents are going to push me in this direction. And then they'll push me in this direction. And then they'll start taking me in this direction. It all changes depending on where I start to float. What if I put my boat over here? You can see it's going to push me in this direction, and then maybe I'll get caught in this, or maybe it will push me toward Taiwan. But if I'm caught just a little bit out, you see that the slopes are actually changing, and then it might take me away, and then it looks like might push me over. What if I'm caught over here? It looks like I'll just end up in this weird kind of circular pattern here. So these ideas is that we are going to draw slopes, and the slopes will tell us an idea what the original graph will have looked like. And these are slope fields. They give us all the possibilities of what your graph should look like. I think this is kind of cool. So how do we come up with slope fields? Let's go back and look at our original one. If you look at this graph here, everything depends on where you start your first point. So if I start my graph, let's put a point right here. You can notice that the slope tells me go up or down. Go up, right? See how it's kind of pushing me up? And you guys ever watch Spider-Man where he web slings from building to building? That's literally what we're gonna do. We're gonna slide from line to line, web sling. Here, whoop, okay, maybe I'm gonna click this one. Oh, keep going up, keep going up. And you can see I'm probably going to go in this direction. What if I go to the left? Oh, look, it's flat here. I'm gonna flatten out and it's gonna start pulling me up. And this is probably my graph here. But what if I'm caught at a different point over here? Right? And you can see the waves are different. The slopes are different. Sure, I'm gonna go up. But you can see that these slopes are kind of heading out in this direction over here. If I go down, we head in this direction over here. So it's all about where you put that original point. If I give you a point, let's say -1, which looks like it's -1 is right here. Which way am I going to go? Well, if you look here, it kind of looks like I'm pushing myself in this direction, right? Maybe not as pretty. Why? Because it would probably be this direction here. So the more points I have, a better accurate kind of guess what this graph will look like. But even if I just use like 5 or 6 points, you can still get an idea what this graph will look like depending on where your point starts. These are called slope fields because they're just change values. They're change values. They are not actual location values. Okay, they're changes. And I've graphed you all the changes. Now you just have to tell me where you want to start. Where do you want to put your boat? If I put my boat here, okay, sure. You guys kind of see the lines kind of start web slinging line to line-ish, right? Something like that. Whenever you're looking at slope fields, it's not perfect, right? This is just a rough idea of what the graph should look like. Oh, look here, look here. Look, do you see how it's slowing down? It's telling me to straighten out and it's coming back down. Now, there are a couple of things that you might want to notice about these slope fields. That if the slope is 0, you end up with a horizontal line here. If the slope is 0, it's horizontal. But I want you to look at right here, this section here. Do you see any lines at all? You don't. And the reason why is if y was 0, look here, 2x over y, 2x over 0. Is that possible? Nope. So this doesn't work, right? This is undefined. We can't draw lines. So they don't draw lines. They don't draw vertical lines, even though it is vertical, okay? It's like an infinite value, an infinite change. So there should be lines here, but we don't draw lines there because they do not exist. Okay? But we know that does trend upwards. Okay? So it depends on where you put your dot, where you put your boat, and then it kind of tells us which way we're going to float. Where you put your boat is where you're going to float. Put your boat here. Whoop. See, so it's all about where you put your boat. Now, how difficult is it for us to come up with a slope field? It is not. All you have to do is pick an x and y value and then plug it in. So let's go ahead and give ourselves an example of that. if I give you, let's say y prime is equal to 2x. That is our slope field. Okay, that's our slope. So let's draw a slope field out of this. Do you know what the original equation looks like? You get a rough idea. It's y is equal to the integral of 2x dx. This gives us x squared over 2 plus c. Remember, we have to add the plus c. So the graph kind of looks like just x squared. This x squared graph plus c. Now that plus c, I'm going to illustrate why this is important to us in a little bit. So let's go ahead and pick up a couple of points. On the AP test, you'll see they'll give you, let's say, 9 points. Okay, let's give ourselves 9 points. So each of these points have an x and y value, don't they? This is 1, 1. This is 1, 0. This is 0, negative 1. Oh, sorry, 1, negative 1. What am I doing? 1, negative 1. Over here is 0, comma 1, 0, comma 0, 0, comma negative 1, negative 1, comma 1, negative 1, comma 0, and negative 1, comma negative 1. So the idea here is each of these 9 points here are on my regular graph. This is not the slope. These are just points on the graph. But what would the slope look like at each of these 9 points? So let's go ahead and start on the upper right-hand corner. If x was 1, 2 times 1 is 2. This is the slope at 1, comma 1. That's the slope, right? So we draw a line graph with a slope of 2. Take a look what I'm going to do. I'm going to draw up 1, 2 over 1. That's my slope. You guys remember drawing little baby steps in algebra 1? You pick a point and you see slope is rise 2 over 1. That's your slope. So literally we are just drawing baby slopes, baby lines. But you're going to draw 9 small baby lines. At 1, 0. Hey, take a look. If I plug in 1 here, 1, 2 times 1 is 2. Hey, the slope's still 2. Turns out all the slopes are the same on this side. Because I don't care what the y value is, I only care about the x. The slope equation says only look at the x. That's all I'm looking at. Let's go ahead and look at 0. What would it look like at 0? Well, fine. What's 2 times 0? 0. So the slope at 0, when if x is 0, the slope is 0. Let me just change my color. 0, 0, 0. Now, one thing you want to realize is there are commonalities to it. Like if x is positive, great. It might change the graph. All the x positive graphs will look similar. If I put x to 0, look, all the zeros became 0. How about if x was negative? If x was negative, 2 times negative 1 is negative 2. So we end up with this downward trending graph. Now, if you pick a point, let's pick negative 1 here. Where do you think this graph is going to push me toward? Sailing, sailing into the next vector. And you can see it's pushing me in this form. And guess what? That is the graph of x squared. If I give you a point, 0, 0, let's say 0, 0 is the point, 1, 1, 1, negative 1, I'm sorry, 1, negative 1. If I said y is equal to x squared plus c, all right? And if I plugged in x and y is negative 1, 1, so 1 equals to negative 1 squared plus c, 1 is equal to 1 plus c, c would be 0. So the graph that we graphed right now was y is equal to x squared. So we can come up with the graph that we're expecting to get from this slope field by plugging in our x and y value. What if I had picked the point negative 1, 0? What would happen if I picked point negative 1, 0? Let's look here. Sailing, sailing over the... You can see that gives me another graph, another parabola. If I go ahead and plug in my numbers, 0 equals to negative 1 squared plus c. 0 is equal to 1 plus c. c in this case would be negative 1. Our equation x squared, y is equal to x squared minus 1. Hey, that's the equation of a vector, of a graph if I start at negative 1, 0. So we can go back and find out what the actual graph is. And the slope field tells us what do all the possible graphs look like. It's like if you guys watch Doctor Strange and you look at those, all the infinite many dimensions, right? You are now become a sorcerer supreme, guys, using slope fields. And as you can see, this point here has, I think, 100, no, more than that. It has 10 on one side, has 10 on the other, says 220 by 20. This is 400 points. And you're not expected to do 400 points, but you're expected to do like 9. Okay, 9, anywhere from 9 to 16. Now for this problem, let's go ahead and graph this by ourselves without Desmos. And we'll use the same equation here. So if I say y prime is 2x over y, let's go ahead and graph 9 points. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. And on AP test, they will literally ask you to graph these dots. Like there'll be dots there, and you're just going to draw lines on them. And these lines, okay, 1 over 1, 1 over 1 versus 1, so 2 over 1 versus 3 over 1, okay? Do they kind of all look the same? Ish, right? Ish. But are they going to dock you because you make 1 over 1 look like 1.5 over 1? No, they won't. But if your 2 looks not as big as your 1, then they'll be like, hey, these angles, they're not bended enough, right? Or what if you put a negative 1 over 1? This should be down. This should be going downward. But if you put up going positive, of course, that's obviously wrong. Okay? So there is some leniency to it, but it can't be obviously wrong. Okay, so here's what we're going to do. We're going to plug in 1, 1, 1 comma 0, 1 comma negative 1. And we're going to plug x and y into all 9 points into this slope, and that'll give us our slope field. Simple as that. Let's start plugging in 2, 1 over 1, 2, 1 over 0, 2, 1 over negative 1. So this gives us a graph of 2. So rise 1, 2 over 1 relative to itself, okay? I'm not asking for you to draw an actual grid there. Relative to itself, I went up 2 imaginary spaces over 1 imaginary space. This was undefined, so I'm not going to draw anything here. Nope, I'm not going to draw anything here because the slope doesn't exist. Over here, it's going to be negative 2. So I'm going to go down negative 1, negative 2 over 1, an imaginary version of that. Okay. At over here, let's go ahead and put these values down. That's going to be 1 comma 0. So it's 2, 1 over 0. Wait, 2, 1 over, whoops, sorry, I flipped my x's and y's. And that's where you're doing this a lot. You end up flipping your x and y's if you're rushing it too much. So that was actually 0, 1, not 1, 0. But of course, you guys want to make a mistake like that. 2 times 0 over 1 is 0. Hey, thanks, 0. And it turns out if x is 0, this is 0 down here, right? Wouldn't that be also 0 because 2 times 0? Doesn't matter. So sometimes you see patterns so you can graph things faster. A couple of things you want to look for to identify a graph is making it 0. So looking here, hey, isn't 2x, if x was 0, if x was 0, all these values would be 0 on the slope field. Now, one thing I want to make note is do not put a 0 here, because if y was 0, 0 comma 0, we don't end up with 0. We end up with undefined, don't we? So make sure you do leave that blank. You could get caught there. And then if I do negative 1 comma 1, plug that in, that's going to be negative 2 over 1, which is negative 2. So negative 1, negative 2 over 1, something like that. If I plug in negative 1, negative 1 comma 0, that's going to be undefined again. And negative 1 comma negative 1, that gives me negative 2 times negative 1 over negative 1, which is a positive 2. So you have 1, 2 over 1. Okay. And that's our basic way of drawing a slope field. On your homework, there's 2 aspects of it today. There is the Kudo Works online, and there's like a bunch of questions where you're going to practice going both ways. You're going to identify the equation given a graph, and then you're going to, of course, identify the graph given the equation, going backwards and forwards. A couple of things to help you when you guys are identifying the equation given a graph is, look, hey, if it's 0 here, if x is 0, find the equation that gives you, if x is 0, your answer is 0. Okay. If this graph looked like, let me go ahead and shift this graph over. if the graph slopes look like this, okay, where x is 1. So you're going to look for x minus 1 here at the top of the fraction. Why? Because if I plugged in 1, we would end up dividing by 0. So a couple of hints. So which of these, if there's a multiple choice equation, which of these would have this x minus 1 here? Because if I plugged in 1, we would end up with a slope of 0. If I end up just giving you a bunch of dots here on the left-hand side, let's say, okay, at -1, because there is no slope, you want to make sure you find an x plus 1 on the bottom, because we would then divide by 0. Divide 0. Okay. So there's different catches, different tricks you can see using some basic algebra 1 skills to see, hey, what am I looking for in the equation so that that matches the graph. Okay. So the second part of your homework today is actually graphing the graphs on a piece of paper. I did put up 8 questions on Schoology through a PDF, and I called it like homework 24 turn-in. So you're going to do that on a sheet of paper. You can, if you guys have an iPad, you can just edit the PDF. That's fine. If not, just do it on a scratch sheet of paper, take a picture, and then upload that, and that'll be part of your homework also. Okay. And that's it.